I'm glad I've get the opportunity to show you or present to you somehow our vision for DevOps in cloud, for continuous automation approach. So I'm Jarek Gajewski. I'm working as a cloud lead architect in the Atos R&D department. I'm also the senior expert in cloud domain in Atos, quite frequent community speaker, one of the co-organizers of Google developer group Cloud Bydgoszcz. And if you would like to reach me, you can find me on Twitter and LinkedIn. That's the easiest way to keep in touch with me. So today, one more important. In the last year, I've got the pleasure to be a technical reviewer, Impact, and on the market you can find a new book for Google certification written by two of my colleagues, Conrad and Brian. So if you are planning to do something with that, I can for sure advertise it. So continuous integration and continuous deliveries are quite commonly used in the public cloud. It's huge rumor around that there, but what about private clouds? What about infrastructure management? During that session, I would like to drive you through 3 stages. On the first stage, I will try to answer 5 whys and how in terms of continuous automation. On the second stage, I chosen 3 key benefits that I see from the automation in the infrastructure world. And at the end, I will show you one of the examples how I adapted it in our SDDC world. Session will be closed by questions. So starting from famous 5 whys and how. Who is the subject of our continuous automation? We are focused on the private clouds as most challenging areas for us, but we wouldn't like to concentrate on that only. We are trying to adapt our way of working to be ready for multi-cloud scenarios and to be ready for any cloud in the final stage. What is the subject for our talks? So Stephen Hawking said that intelligence is capability to adapt to the change. So to properly adapt to the change and to properly go forward with your continuous automation, with your DevOps, with your CI/CD or whatever you will find out, you need, in my opinion at least, go through those 3 key aspects. You need to go through the continuous design, you need to go through the continuous integration and continuous delivery in the final stage. Everything is starting from the idea. But the problem with idea is that very often you need time to implement, to make it happen, to implement that idea. Very often the environment is changing. It's quite common that your approach is changing. It's quite common that if you are delivering that for an internal or an external customer, a customer will change their mind. You will figure out that something has significant impact in that what you already designed. That means that your design would need to be flexible and need to introduce as less constraints as possible. It's not easy because that means that you need to think somehow out of the box. You need to look at the things from the different perspective. You need to spend more time with consulting with other colleagues. Really, if you have capability to talk to people, do it. It can save huge amount of time for you in the future, and it can provide you capability to create designs that will answer for the future changes, problems, and so on. Next The implementation phase for continuous design is continuous integration. Continuous integration, from my point of view, is fully relying on unit testing and integration testing. If you've got good testing automation in your pipeline process, believe me, you will reach better results, because the code of your quality, the quality of your code will be far more better, and you will be able to concentrate on the development work instead of thinking what will happen if. Last of the aspects is continuous delivery. That's most visible for the end users. That's something that mostly engineers are forgetting to keep proper attention on. Even if you will spend huge amount of time and huge amount of energy on continuous design and continuous integration, but you will not deliver that in the proper way, probably someone will not see that what you've done in the past. Unified testing approach provides you capabilities to adapt those customer changes into product that already exists, to figure out what is the impact of those changes almost immediately. I will cover that in a second, but that's really important. And last but not least, the continuous automation approach for your scripts, products, or whatever you will keep behind, force your R&D people and your operational people to cooperate. They will need to cooperate. They must cooperate. There is no way to do something in the DevOps methodology or to introduce CI/CD approach if those people will be divided into two different worlds. So we already covered the what part. I already started to talk about when we would like to introduce continuous automation. When, from my perspective, it's important to bring it there, and where is the place when I will get biggest benefits of that. I'm working with private clouds for last 7 years, and deployment was always the painful. It doesn't matter if you are doing the solution deployment or you are just injecting your scripts into production environment. But the more challenging is the lifecycle management. If you already created your code, if you created your playbooks or whatever, but you don't have proper control on that, you don't have proper automation behind, probably any LCM activities on top of your product code playbooks will be painful. And those are two areas where I would like to focus for continuous automation. My implementation was focused on the data centers. So we are delivering infrastructure. We targeting initially everything for my own data centers, but they can be also the customer data centers. If you will prepare your design in proper way, it can be in fact any data center. And that's the area when you should that you should take into account. The entire story wouldn't be full if I wouldn't say why we decided to do so. So, starting from engineer and ending on the manager, if you can predict the time, and if your manager can predict time and cost, you both will be very happy. Continuous automation provides you that capabilities. DevOps approach, CI/CD provides you capability to predict how much time, your time, will be consumed for that particular task in the future, in the operational world. Same for the efficiency. So there was many studies, starting from Oxford to Cambridge and other stuff, that automation increasing efficiency. People are making mistakes. Scripts not. How we achieve that? So, go on. We incorporated within Atos 3 principles. First, we started to commit our code into shared branch on the daily basis. That means that every changes that our developers made were immediately available for everyone, every other developers. Secondly, as soon as code is committed, we are triggering automated builds and automated testing that allows us to achieve the third goal, that is immediate results. Immediate results provides us capability to troubleshoot problems almost next day. If the testing pipelines are going through your code during the nights and your developer is coming back to the work on the next day morning, he is fully aware of what he has done yesterday. Is anyone on there was anywhere anyone there trying to introduce such approach to commit to the shared branch? So we are using feature viewer. That's for you. You are the winner. It's not common. So in the software development, it will be for sure not common. In the software development, it will be easier to use feature branches and so on. But when we are talking about infrastructure, the feature branches assumes that at the end, when you are doing the release, you've got a duck. And the duck knows everything about all other developers' work. And is able to review the code, find the problems, solve the problems, and do that in 8 hours. Better if he or she can do that in 4 hours. That solves a huge amount of our problems in the infrastructure development. So now I would like to present to you 3 benefits that I chosen. There are not any rational why. I just decided to focus on the cloud agnostic approach, flexibility, and beneficial. First, we divided our entire CI/CD, our entire pipeline, into blocks. That allows us to decide which block is valid for the particular run, particular build, particular deployment, particular LCM. That allows us also to inject new customizations or any other stuff in the middle of the blocks without impacting the entire sub-pipeline. All what we created is defined as an infrastructure as a code. That means that we always know what is the desired state of the infrastructure as a service. Our or your management stack, everything what you are injecting on top of that should be cloud agnostic. That means for me that even if I'm currently focused on the VMware SDDC, and I will decide to rely on my management stack on VMware stuff only, I'm done. If someone will say, I would like to go to Google, that means that I need to redesign and rebuild it from scratch. So in our case, the management stack is cloud agnostic. We can place it anywhere. Same with API. If the tool that is serving proper services for us do not have API, that means that we will not choose it. Graphical user interface is only supportive for operations, but it's not key interface for doing any activities on our SDDC. Also, if to adopt proper testing scenarios, you need to have a way to inject your tests into your pipelines and try to use out-of-the-box functionalities. Looking at the flexibility, all of our stuff is variable-driven. We are using Ansible to do the entire pipeline automation. We decided that we will place on top of that Python script to properly handle errors. In Ansible, is there any way in Ansible to handle errors and to react on that? Yeah. How can we do so? Yeah. How can we, on which level we can do so, for example? Okay. Okay, we decided to not use handlers because there are some limitations around that area. But there is, I've got a guy who knows that. Almost on every level of our automation, we don't have hard-coded values. So every time when we are finding that someone make mistake and hard-coded something, we are changing into a variable. That allows us not only to inject into our code data that is always different. We've got it, fine. But what if someone would like to change Ansible version or whatever? I don't want to go into particular playbook, particular role and change that in the code. I want to go get that data from the variables. Do you know where we can define variables in the roles? And what should I do, guys? I've got only one more. Yeah. Okay. Everywhere. Many places. And as soon as you've got your organized, it's really useful. I already mentioned about automated testing. It's really increased flexibility. And you know, we are developers, we've got our code repo, and we are going to the customer. Customer is deploying his SDDC. And what else? What should we do to make sure that on his premises, we've got still data that is representing desired state of the infrastructure? We just equipped that customer in the code repo. We are using one currently. It was already mentioned about GitHub. Do you know any others code repositories? And? Bitbucket. Okay, who said Bitbucket? Oh, I can, no. Okay, so that's for you. You were on the GitLab. Yeah, that's true. We were using Bitbucket. Now, for some reasons, we moved to GitLab. One of those reasons was I like GitLab more than Bitbucket. And last but not least, as engineers, developers, architects, we love to complicate things. Make it simple, really. Sometimes, Lucas has time, when guys came to us and showing how they implement automation, you would never think that it can be done in that way. If you can, just use modules. If you can, just use APIs. Do not try to complicate your life. Do it in a simple way. Do not complicate it. If you are not able to understand your own code after 1 month, that means that it's crappy. If you are not able to understand it next day, that means that you shouldn't be a developer. Okay, so key benefits. Yes. That's what is important for our managers. Automation, CI/CD, all stuff is decreasing operational costs. In our case, it's Atos. That's why you can achieve more. Your ideas can be taken into account. And what is most important for me as an architect, it's reduce entropy. Even if you will create great work instruction and someone will have pictures and you'll bold the text, probably 5% of guys who will do so will make mistake. If you've got everything defined as an infrastructure as a code, if you've got everything defined in variables, if everything is automated, it's predictable. You have the environment and state in a way how you defined in your configuration files, Jinja templates, and so on. Simplicity provides you huge benefit in terms of solving problems. If everyone there, you have a chance to be on the standby? When you are, when they are calling you at 1 a.m. and you're trying to figure out who are you and why are you calling to me? When you've got your environment defined in the proper way, you've got everything defined in a simple way, probably the amount of errors and downtimes will be reduced. Probably, I'm sure. I know that there are cases, and one important remark. You can cheat your automation. I know that. And I cannot do anything with that. It's if someone will decide that he or she would like to cheat your automation, it will be achieved. You can try to prevent it, but it can be done. Okay. Now I would like to show you how we are, or one of our way of working with that. So it's common practice to have multiple environments when you are testing your code, scripts, or whatever. In our case, it's development, integration, test. Why? Because we are doing huge product. If you are just writing a code and you are internal for your own company, probably you shouldn't do that on the production, but one environment will be more than enough to achieve the goal. Quite common problem or quite common issue that we can find is that you've got splitted that into pieces, and behind you've got one huge testing team. The gods. Probably same guy can test your code in development, integration, and test, make exactly the same mistakes, and code with the bug will go to production. We changed that approach. We don't need test team. We've got great developers. They can test their own code themselves. And we are doing the cutoff on multiple places when another team is stepping in to check how the code quality looks like from their perspective. The development and integration is fully automated testing backed up. The test environment is the area where people are also doing the graphical user interface testing. We are using, for example, GDG Cloud. So, of course, we can use APIs to test if everything is working fine, but we would like also to have a human factor. So guy who will have a look at the forms and will say they are awful or not. Automation will not check that for us. In the development environment, you can experiment. You've got idea, you've got automated testing behind, just inject the code, check how it's working. If it's crap, move back, try again. In your test production environment, there you need to have discipline and you need to have quality. That means that if someone will call you that he has a problem here, you shouldn't inject the code there. You should inject it there, go through all stages, and then move to the production. I know that it's not easy, especially when you've got escalations. So that's our show demo approach. We've got our code repository, we've got our image repository, and we decided to automate entire stack. So in the past, we are using vCloud Foundation. vCloud Foundation for the initial build required some prerequisites. In the past, we were providing to the data center guys and other people requirements. Nice document. You need to deliver for us that, configure it in that and that way. Łukasz, how many times we've got 100% met requirements? No. None. That's true. every time something was not in place, or every time something was misconfigured, and so on. So we decided to build a prerequisites in an automated way. You are providing for us the variables, whatever you want. I don't know, location of data center, IP addresses, whatever you want in your particular case. And our pipelines will build prerequisites for you. You just need to ship that machine to the data center, power it on, and voila, it's working. There is a human factor. Someone needs to import it and power it on. So still area for improvements, but I don't know how to fix that yet. Then we are going to the out-of-the-box VCF bring-up process. Why we decided to go into that way and not automate it through Ansible? Because we don't want to do the reverse engineering. VCF is released every 2 months, and every 2 months they are changing huge amount of things inside. So we decided to rely on the out-of-the-box for now, but it will change for sure. Then entire configuration of the VCF and entire configuration of our management stack, whatever you want to place on top of that, is done through Ansible playbooks with the automated unit testing, and we backed by automated rollbacks. So our Python script is gathering results of the plays. If playbook will fail with particular reason, we are doing the rollback. If you want, we can try to redeploy it again. It's still the flexibility. So we not force people to act in the particular way. If you will decide that you want to go forward, even if it will fail, you have such option. Just choose it. When we've got our management stack ready, we are switching into configuration for the customer payload, workload, domains, and other stuff. And when all of those is finished, we've got all unit tests passed, we are switching into integration testing scenario. In the integration test, we are checking if the particular components that in theory are healthy because they passed unit tests, if the particular components are cooperating with each other in the proper way, and if any issues are found out, in our case, we've got integration with Jira, so stories, bugs are created in Jira to notify developers directly that something is wrong. The reason behind that is that even if you will decide to go forward, even if you will find manual way to fix it, in the next iteration, we would like to fix that problem in the automated way. And again, we've got those two words. One word is the operational, second is R&D. DevOps means that they need to talk to those guys. They can forget because they've got something else to do. If you will back it by the tooling that is properly injected in the automation, all issues will be automatically advertised to R&D. Last part is also something that is commonly missed. We are done. We deployed our SDDC, for example. Now it's time to document. I don't have time. I need to go forward. I need to do something else, and so on. So we are injecting the continuous documentation. 10 months ago, we decided to drop Word and move to the Markdown. I think with success even. Markdown provides us capabilities to generate documentation if required, to provide proper templates. We've got multiple Jinja templates that are just gathering data after deployment and providing it to the customer and injecting that into customer code repo. So for the operational team, they've got single point of the information for entire infrastructure. They've got their code, they've got their documentation, and everything is versioned, everything is up to date. Going into lifecycle management, I don't know if I've got enough time, but I will start to speed up. Try to speed up. So it's the same story. To do the LCM upgrades or whatever on your environment, you need to check in which state is your environment. if you've got desired state of that environment in the GitLab or any other code repo, you can just grab it and your automation can check if the desired state is still in place. On top of that, we need to grab data from the logs to make sure that there are no errors there, and to grab data from the health checks. In our case, it's, for example, VROPs, to be sure that environment is a state that allows us to go with the LCM activities. Then we are doing the staging, when all data or binaries, code, and so on is already staged in the particular SDDC. We can go through the upgrade pipeline. Blocks, all of the blocks can be impacted, but not always, depending on the range of your LCM activities. Again, is backed by testing and documentation. I hope I've done it in half an hour. So now the floor is yours. If you've got any questions, feel free to ask me now, or you can grab me somewhere or find me somewhere there.